Hello and welcome to How to Manage and Configure Highly Available Mission Critical SAP Applications on AWS. My name is Alexis Burnett and I'm the Global Senior Director of Marketing at Syntax, and I will be your host and moderator for today's presentation. When you join today's webinar, you selected to join by either phone call or your computer audio. If for any reason you'd like to change your audio selection, you can do so by accessing your audio pane in the control panel. From the control panel, you'll also have the opportunity to submit questions to today's presenters by typing your questions into the questions panel. We will collect the questions and address as many as we can during the Q&A session at the end of today's presentation. Also at the end of today's event, there'll be a brief survey. Please stay connected until the end of the broadcast and submit your feedback, as your opinion does count. Lastly, a recording of today's presentation will be available on YouTube via an email that will be sent 2 to 3 days after the conclusion of the event. So do keep an eye out for the follow-up email sent to the address you provided when registering. So again, welcome to today's live webinar, How to Manage and Configure Highly Available Mission Critical SAP Applications on AWS. Again, my name is Alexis Burnett. I'm the Global Senior Director of Marketing at Syntax, and I'm going to be moderating and hosting today's webinar. Thank you so much for joining us. I'm happy to announce our speakers today. First and foremost, we are joined by Matthew Lobaugh, Global Industry and ISV Partner Lead, SAP at Amazon Web Services. We're also joined from the Syntax team by Colin Dawes, Chief Solution Architect at Syntax, Ryan Frazier, Senior Systems Engineer and Team Lead at Syntax, and Antonio Tavera, SAP Cloud Specialist at Syntax. Today, you will learn how to run a highly available SAP infrastructure on AWS, and you will see a failover demo from Syntax. And remember to please post your questions in the chat box throughout the event. At the end, we will review all of your questions at the end of the session. So let's kick it off. I'd like to introduce you now to Matthew Lobaugh, Global Industry and ISV Partner Lead, SAP at Amazon Web Services.
Thanks so much, Alexis, and hi, everybody. I hope you're all staying safe, and on behalf of everyone on the team here, we hope that you're doing the best you can in these difficult times. Nevertheless, we did want to get together and share some ideas with you. I've been in AWS now for about 3 years, and I've been on the team that's been helping to develop our strategy and our offerings, and also working with SAP-focused partners. And speaking of partners, we do about 80% of our customer engagements either with partners or they're either including partners or run directly by partners. So the partners are a big part of how we actually help customers at AWS. We've got about 5,000 customers today that are running their SAP environments on AWS. So if roughly 80% of those 5,000 customers have been working with our partners, you can imagine that our partners have actually grown to build their practices and have hardened their skills and their capabilities quite a bit as they were building on AWS. Because ultimately, AWS is a platform for builders. We're very happy to have as rich a platform with as many features and as many services and things that you might want to configure and use. It does, however, present a little bit of a double-edged sword in some cases. On the one hand, you have the ability to build just about anything, from the simplest app or connector to very complex capabilities. On the other hand, not everybody really has a very well-staffed and large IT organization and wants to build everything, from the get-go in-house, which brings me to why we're here today. Today we have customers like AIG, the large insurance company, or Whirlpool, the consumer manufacturer, consumer products manufacturer, or for instance Seco, one of the largest shipping container companies in the world, and many other customers that are using AWS for their high availability strategies, and they're running their mission critical production environments leveraging the AWS infrastructure. It can be kind of tricky to set up, and we have seen that customers sometimes can be a little bit confounded by the choices that they're presented as they try to figure this out. And so what we're going to do with our colleagues at Syntax today is unpack some of your options and to kind of get a good look at what some of the best practices are. So enough of that. At this point, I'd like to turn the mic over to our friend Colin. Colin?
Okay. Thanks, Matthew. I'll just say a couple things about Syntax here, give you a brief introduction to who we are and what we're all about. And if you have any questions, you can always follow up later. But let's get started with a quick intro to Syntax. So it won't take too much time, but Syntax, we've been in business for over 45 years, over 1,200 employees globally, have been supporting SAP for a very, very long period of time, and have been doing cloud and managed services for over 25 years. We are a global company with multiple locations, data centers, and offices across the globe in various different countries. If we had one snapshot of a slide that said what we did, we're really organized around ERP cloud solutions for both SAP and Oracle, whether it be private or public cloud, as well as application managed services and consulting around that. So we take over the back office management of the ERP. We do as much or as little as companies want us to do. We also offer consulting services for installations, upgrades, associated technologies associated with that, what we call the ERP ecosystem, because there certainly are a number of different add-ons to these different products. And of course, we do offer public as well as hybrid and private cloud solutions in a variety of different clouds. Just a quick snapshot. We have over 40-year history with SAP. We're about the 7th customer of SAP. So we have been doing this for a very, very long period of time, and are well known throughout the industry. So over to you, Matthew, just to say a few words about AWS.
Sure. If we could go to the next slide. AWS, as some of you may know, really kind of started the whole idea of the public cloud, and to this day, Gartner continues to position AWS as the infrastructure as a service quadrant leader. It's probably worth noting that if you go out and take a look at most of the analyst reports, we continue to be recognized for the breadth of services and the innovation acceleration that we can bring to customers. And that's probably all we need to say there. We can move on.
Okay. So I'm going to start with a bit of a high availability primer. This is a solution that comes in various different forms. We're going to present to you one flavor of this as we go through the demo. There's many different permutations here. So one of the first important things to understand is what are the basics around high availability? I know we've got some very senior technical people on here, but we also might have some people who are not fully aware. So we're going to have to start a little bit at the beginning here. So high availability, essentially, it's just the ability to have system or other components continuously operate for a long period of time. It's computers, it's IT, things will often fail or go off the tracks there. So high availability allows us to build in some redundancy so that we can quickly recover. And the key is there's minimal interruption to the end user. So we're really looking at things in terms of the end user when we define this. Now, when we talk about high availability, it's not going to be for everyone. So certainly this is not the cheapest or the lowest cost solution. And what we'll often contrast this against is disaster recovery. So often individuals, organizations, well, there'll be some confusion between these two terms. So let's first define what these two are. So high availability and disaster recovery, we're really looking at two sides of the same coin. So it's really the same problem. So it's about keeping those systems up and operational. However, high availability is really meant for when the system is actually running. Hey, we had something fail on one system. We want it to automatically fail over. We don't want to interrupt the end user. Whereas disaster recovery, this is after something has already failed. What do we actually do in those particular circumstances? So disaster recovery is really that entire plan to recover all your critical business systems if there's a catastrophe, whether it be fire, weather, tornado, cyber attack, or anything that's going to cause significant downtime. We're going to show you here how high availability can actually be a component of disaster recovery. So you don't have to separate and segregate these two. High availability can be part of and be, for all intents and purposes, also part of your disaster recovery solution. So as long as we have a replication of one-to-one of all the various different critical components, we can continue to run the business. So in terms of determining if we actually need this, some of the key steps that we need to do is what's the impact to the business if critical systems are unavailable. If you wanted to determine a cost, you can take your yearly revenue, divide it by the number of days in the year, divide it by the number of hours, divide it by the number of seconds, and then you get your loss per second. So what would be the business impact if your systems are not available for a certain period of time? We also wanted to determine what we need to recover and when. So by priority, ERP systems, pretty much you need them immediately. They're a key and critical system. We also want to take a look at your tolerance levels. With the power of the cloud, especially AWS, we can have different tolerance levels at different dates, times, or seasons. So for half the year, you may determine that, you know what, this is our busy season. We need to have high availability for these, 4 or 5 months. However, at other certain points of the time of the year, you may not need that. So you can scale that down and scale that up as required. Also, establishing these requirements are going to really help determine what is the solution that we actually need here. Is it HA? Is it disaster recovery? What form of high availability? What should be the overall configuration? And how much we should pay for that. So we always want to put a cost on these various different items. So how do we determine the tolerance level? Now we're going to take two terms that are often assigned to disaster recovery, RPO and RTO. The real bullet point here is if you have an RPO that's approaching zero and an RTO of approaching zero, that's about the time you're going to start considering high availability. I don't want to have any interruption to my end users. I'm running a call center. I'm doing a service desk. You have other critical activities running. You really can't afford any minimal interruption throughout the day. If you can afford to be down for 24 hours and lose up to an entire day's worth of data, then you're probably better off with a different solution such as disaster recovery. Your requirements are simply not that critical to require a highly available solution. So within the cloud, high availability in the cloud is not something that is automatically there. There's a common misconception that if you throw your stuff in the cloud, both the applications and the infrastructure are going to be highly available. That is not necessarily the case. Cloud technologies, they can enable these applications to be highly available, but we're looking at what's more the traditional ERP, or some ways they may be seen as legacy applications. So they're not out of the box built as fully redundant for the cloud. Now, what we can do with the cloud is we can take these applications like SAP, re-engineer them, use some of the cloud intelligence to make them a lot more fault tolerant, and we can do this at a much lower cost than we could do on premise. Because all of the high costs for routing, switching, load balancers, that's shared across the entire cloud. So really, the key to building high availability in the cloud is not just through the architecture, but it's the infrastructure, the architecture, as well as the applications themselves. So if we take a look at the infrastructure versus application high availability, so if we start at the bottom here, AWS, they provide the resilient infrastructure, so that's the networking servers, the virtualization, and they eliminate all the single points of infrastructure failure within the infrastructure and also provide redundancy. So it's also still important that we back up all the systems. So that's something that Syntax as a partner would help navigate what the retention times, what the retention policy is. Disaster recovery, also still critical and important. So again, that's for a longer term RPO, RTO, whereas high availability, this is something that we can enter at both the infrastructure and the applications. AWS takes care of that from the infrastructure standpoint. Syntax adds our intelligence and automation for the infrastructure, and we certainly do add that for the application level as well. So if we're taking a look at the overall spectrum here, so what we see here right at the bottom is replication can take us so far until we need to have greater availability, very much reduced downtime. So that's where we rely on clustering or mirroring technologies. So infrastructure high availability, if we take a look at the big boxes, typically if we're doing things just at the infrastructure level, if there's a failure, we may have to do a manual application restart. That means we got to restart all the applications, and manual application repositioning means you have to go back in, you may have to delete things, clean things up, and tell the user, go back to exactly where you were. We can also move on to a little bit more automated application restart. So an automated application restart is going to put some intelligence in there where things start up again in the proper order and go through their validation. Application high availability is where we now have to start adding some intelligence, leverage some cloud native tools so that it's going to automatically bring things up, detect those failures early enough, fail over automatically before those end users go down. And then finally, more towards the no downtime. So this is full application resilience, automatic application restarts, and what we call transparent application failover, or TAFT. Now, TAFT is not something that any of these more traditional ERPs support natively out of the box. They simply were not designed at that point in time, but this is what we are here to do, to engineer into the application as best as possible, to have as transparent a process and as transparent a failover with minimal interruption to the end users. So with that, we'll turn it over to our colleague, Ryan. Ryan, are you there?
Yeah, for high availability for SAP on AWS. For this section of the presentation and demonstration, we'll be using SAP Business Suite S4 HANA. The SAP Business Suite is designed to run only on SAP HANA. It uses modern design principles called SAP Fiori UI and addresses all functionality of SAP ERP central components. Along with that is the SAP HANA, with its advanced in-memory platform and operational database systems.
Okay, so just one of the things that we take advantage of here is, now we know which version of SAP, we take advantage of a number of unique features of AWS to ensure that we have full availability. So back to Matthew just to talk about some of those quick features.
Sure, thanks, Colin. At a high level, what AWS really is a global platform. It's globally available infrastructure. What you can see here on this slide is where we are currently. Today, we have 24 geographic regions. We think of our starting point for having a discussion about this as a regional location. And within those regions, we have availability zones. Today, we're in about 42 countries, something like 84 cities, and the infrastructure is a mostly global footprint, and we can really deliver content or deliver data and information through this this global platform pretty readily and with a great deal of resiliency. You can see here that most recently we've opened up some locations in Milan and Cape Town in South Africa, and we've announced additional regions that are going into Indonesia, Japan, and Spain. So we're going to continue to grow this footprint, and we typically do that based on where customers are telling us we should go next. And if you go to the next slide, I would encourage everybody that is considering moving their production environments into AWS to really get educated about this idea of our regions. The AWS regional design and how it works with the availability zones is actually still unique. There are others that do things that are similar, but it's worth trying to understand the differences. AWS is really built the regions with the idea of multiple availability zones, and it's built with to be highly available, highly scalable, and highly fault tolerant. Each availability zone has one or more data centers that are in the availability zone. And you can think of these as a modern data center that has all of the heating and cooling and power and things that you would normally associate with a data center. And in an availability zone, the data centers are physically fairly far apart. So you can think about that in terms of miles rather than a availability zone being in one building and then across the street in another building. So we purposefully architect these regions and availability zones to create a lot of redundancy. The data that is stored from different applications and systems is replicated across the availability zone, so that if we have any kind of a failure or issue in one, you're covered. And so that's one of the big reasons that people tend to consider AWS when they're talking about their production environments. And lastly, on the next slide, one other thing to realize is that we actually also have the network all pretty much set up and secured. Once your data comes into AWS, we have a redundant 100 gigabyte network that has redundancy between how it's all stitched together. So it's pretty darn fault tolerant. We don't really end up with interruptions, generally speaking, because we've just cabled everything together on our own private backbone. We don't use other public providers' backbones as we to have this available. And to give you, for instance, in 2018, IDG did a study of over 100 IT professionals that were running SAP on AWS, and over 20%, 28%, I think it was, of them reported that after moving their production workloads into AWS, that they experienced better uptime. And I don't know if you've ever gone into a room of CIOs and said, how many of you are experiencing really bad downtime? They don't usually raise their hands, but generally, but you can get them to admit that they're getting more uptime. And we do hear about that pretty frequently from our customers when they move their production environments into AWS. So I'd encourage you to reach out to me or to others and to get to understand the infrastructure that this is all being built on. But to Colin's point, having it all there doesn't mean necessarily you've got it configured correctly. And there are some specifics about how to run SAP on AWS. We do have a very large portfolio of certified offerings that are SAP certified, but how are you going to put them all in there? It's probably a little bit of an art form. So back to you, Colin.
Okay. So Ryan's just going to introduce us to the system components and how it forms the basis of the HA architecture.
Yeah, so for a SAP S/4HANA standard configuration, these are the components that are typically used. You have your primary application server, and then if you want any higher availability with that, then you would add any additional servers, application servers with that. We then have the ABAP SAP centralized services, and on the back end, you would have the SAP HANA database. As you can see with this design, you have two main single points of failure. That would be, of course, the centralized services and the HANA database.
Okay. So in terms of high availability, what we need to incorporate into the strategy are a couple of different concepts. So in terms of overall strategy, you have to eliminate single points of failure, which AWS does for us, provided through the infrastructure, the network, and the applications. We also need to have a multi-site configuration. It's really no advantage trying to run high availability within the same data center. You need at least some geographical distance between those. And that's what the AWS availability zones provide for us. They provide enough geographical distance between availability zones that they're not going to get this, be on the same power grid. You're going to be, miles and miles apart. So that's what AWS also provides us. And what we do from a syntax perspective is we just pick the appropriate zones. So that's why our logo is up on there as well. Balancing and failover. So you need to have a reliable connection and failover mechanism, and you have to implement that within the application. AWS provides a lot of the building blocks, but you need to stitch those building blocks together in order to get a workable solution. So that's what we do at Syntax. The high availability application awareness, I think it's pretty obvious that applications engineered around the era of SAP don't have full application high availability built into it. It means they don't support transparent application failover. They're not stateless connections or anything else. So we have to build some intelligence into the application, and that's really why we're here and what we'll kind of see in the demo. And of course, there's going to be pros and cons and different things that happen at different stages of failover. Monitoring is what our secret sauce is. Syntax has been at the SAP game for 40 plus years. We've built a lot of intelligence, a lot of monitors out there to continuously monitor not only the infrastructure, but also the applications. So we can do some self-healing, remove things, add them back through predetermined processes. And of course, finally, you have to test, and retest, not just before you go live, but also on a regular basis. So back to Ryan to talk about our high availability solution.
Thanks, Colin. Yeah, so unlike our last slide that we had with a typical setup, as you can see with this HANA high availability here, we are actually spreading everything across multiple availability zones, and then along with doing that, implementing clustering on both the central services and the database backend. We also utilize such services as EFS, and then snapshots, and then AWS S3 for backups. Okay, so with Syntax solutions for SAP S/4HANA HA on AWS, the distributed deployment with the SAP suite applications and the HANA database on different compute instances, that helps create resiliency. Also, with the high availability of implementing using server clusters. So most common methods for increasing application availability. The challenge is making each tier cluster aware. The Syntax HA solution for SAP on AWS is differentiated in many ways. This would be some of the services that we offer, which would be the Syntax Autonomous Platform. This is used for things such as, let's say, automated restarts of a failed instance. You'll actually see a little more about this on another slide. We have the Syntax EnterpriseCare. This is for advanced monitoring. Again, you will see this on a separate slide where Colin will go into more detail about. And then we have the Syntax portal for AWS. This is really used for to provide transparency for the customers when it comes to their AWS infrastructure. As you can see on the right, these are a number of the services that we use to accomplish this high availability. That would be, Amazon's EC2, S3, EBS, EFS, ELBs, and then S3 Glacier, and of course VPCs, and then using things like GuardDuty and CloudWatch for monitoring.
Okay, thanks, Ryan. So just a little bit about their intelligent autonomous platform. Ryan did mention a couple of things. I'll only touch on the items that are important to high availability. And really this is about monitoring of the application. So we use autonomous computing here, serverless computing with some extensive monitors that have been built out specifically for ERP. And we use this to not only monitor, but also correct things, cost optimization. So this is how we detect if things are going to potentially go down, not just at the infrastructure level, but also at the application level as well. So it's important to build that level of expertise, monitoring directly at the application level. Also mentioned our EnterpriseCare. So this is a cross-platform portal it is a multi-cloud portal where we can do infrastructure monitoring, look at latency, monitor databases, look at logs. Our customers have access to that real time to see what's going on in the portals. They can see, who's on their system at any given time, maps of their infrastructure. So very useful in terms of self-service, but also you can see the real-time monitors and the predictions whether or not any particular component may be experiencing issues. So Antonio from our SAP side is going to take us through some of the failover items.
Hello, everyone. So how do we achieve high availability at the application server layer? From the application server point of view, the key is the numbers of these application servers. At a basic level, you need at least 2 application servers, primary application server and additional application server. SAP achieves this load balancing through logon groups. Logon groups in SAP are a group of servers that belong to the same SAP system and are typically to distribute user logons to each application server. If an issue hits one of the nodes, all users connected to that node will be kicked out, but users will be able to log in as the other application server will be up and running. Thank you, Colin. Okay, now I'm going to talk about how to achieve high availability in one of the main single point of failures of an SAP architecture, the SAP Central Services. For the Central Services, we recommend the recommended procedure is to use NQ Replication Server or ERS. Central Services and ERS are installed on a shared disk in both hosts. NQ Server will keep the log table, and the ERS will keep a replicated copy of the log table. A third-party cluster software will provide the automatic failover mechanism for the ACS instance. In this case, the third-party cluster software that we use is a set of dedicated libraries developed by SUSE and certified by SAP. What this means is that you have central services and a ERS on each host. So if at a moment an issue has to hit one of the nodes, it would automatically fail over to the other node on keeping the system alive. Shared disks along with the overlay IP is also failed over. Thank you, Colin. This is the other main single point of failure of an SAP architecture, the database level. We achieve this by having 2 databases where one is set to be the primary database, serving the SAP system data, and the second one is a standby database, which is supplied with a constant feed of data from the primary database. On top of that, you need a cluster software. In this case, is SUSE Enterprise Cluster, and an automated failover mechanism. This means that the cluster will be pointing to the primary database, thanks to the overlay IP. If that node becomes unavailable, the failover mechanism will kick, and the standby database will become the primary database, effectively keeping the system running. Thank you, Colin.
Okay, we're going to switch over at this point to a live demo, which will be annotated by Antonio.
Okay, today I'm going to show you failover on both the central services and the DB cluster. So I'm going to show you how they works. Now I am showing here the centralized services cluster along with the NQ replication servers. I'm showing that all of these tests must pass, so the failover mechanism triggers without issues. So these are prerequisite for a right configuration of the centralized services and ERS software. This is going to be a soft failover. So I'm going to trigger the failover by command. So it won't be like a failure simulation. And it will take only minutes to do that. So I am showing another component of the configuration. And finally, I'm showing that we are using SUSE Linux Enterprise Server. This time is version 12, support package 4. Okay, so I'm going to show you now the status of the cluster. So we have the overlay IP mounted on node 1. The centralized services is running on node 1, and the NQ replication server is running in node 2. What I'm going to do now is to show you the NQ log table. Of course, this is a demo system, and the workload is kept at the minimum. So the NQ log table will be empty. So right now there are no logs. Of course, in a production environment, we will have 100 or even thousands of log entries here. So what I'm going to do now is to create one log entry by editing one user, and this will log the user table for my session. So this is the edit mode, and okay, the log entry is there on the system. So right now I'm going to trigger the failover. So I'm going to failover the centralized services from node 1 to node 2. So, okay. Okay, so the instruction has been triggered, and the cluster immediately picks up the command. So let me show you the log table. So right now there's one small disconnection. So this is what a failover during productive hours will look like. And as you can see, it was seconds. So the system is back online. And as you can see as well, the log entry was not lost from the table. So all of this table was kept consistent, even though we are moving this service from one node to the other. This cluster is configured to have the centralized services and the NQ replication server in separate nodes. As this was a soft failover of the centralized services, it will simply move the NQ replication server to the other available node to keep consistent this configuration. Of course, in case of server failure, the NQ replication server would stay in that node, and both services would run on the same machine without issues. I'm going to remove the log entry. I'm going to exit editing this user. And now, yeah, the block was released. So this was a failover of the centralized services NQ server cluster node. So I'm going to tell the node that the migration is over. And just to confirm, so now the NQ replication server is in node 1, the central services is in node 2, and this is the previous, sorry. So this is the final state of the cluster. So now let's go to the database cluster. What I'm showing you here is the replication configuration. So this node 1 is the master, the node 2 is the slave. Both databases are in sync. So the cluster is working fine. So I'm going to check the database status from SAP. So this DBA cockpit. Okay. SAP reports that the active node is the host 1, AWS DB 01. Let me log back in. Okay. And now I'm going to show you the cluster configuration. So that was at database level. This is at cluster level. So we have the IP on node 1. We have both HANA resources running on both nodes because one is one master, the other is the slave, and the cluster knows which is the master and which one is the slave. Okay, so this is the good part. So I'm going to simulate a server crash. So what I'm going to do is to shut down entirely the primary node of the HANA database. So it will just go away. So I'm going to stop it directly from the console. Okay, we lost connection from SSH. The node 1 is gone, totally gone. So let me monitor the cluster node from the available, the cluster configuration from the available node. And as you can see, right now the failover is happening automatically, and there's a little application freeze. This is again, this will look like this. If we have a failover or a failure during productive hours, we'll have a small amount of disconnection there. As you can see now, the IP has been automatically moved to the secondary node, and the database is doing automatically the takeover. So the once secondary node is now becoming the primary and will take over the operation of the SAP system. And this take 2 or 3 minutes more to complete. So this whole mechanism is totally automatic. So it's still trying to connect to the new database on, yeah. So it's back online. So it took about 4 minutes to do a complete failover. The system is back, although we lost the entire primary box. The business still up and running. And now SAP is reporting that the host name of the database is the secondary node, is the AWS DB 02. And yep, the cluster is reporting that the new configuration is like that. So everything was moved to node 2. And now the master is the secondary node, and it knows that the primary server is down. So it reports the server like stopped. Thank you very much for watching.
Okay, thanks, Antonio. So just wanted to summarize with a couple of considerations here. So as you saw, really 24/7, 365 uptime is possible. Mostly, there's different user experiences depending on where things go astray, but certainly this is a much better solution than simply having a prolonged period of outage. So high availability also creates a very scalable architecture, because this is really impossible to outgrow. You can really scale this across, AWS regions within a region, and really you can size this up to whatever you need it to. Through our advanced monitoring and automation, we can create a self-healing environment. You need to be able to monitor, predict things, not just at the infrastructure level, but also at the application level. And pretty much near zero data loss, so an RPO pretty close to zero, and an RTO, recovery time objective, also pretty close to zero if the central services or the database fails. However, there are a few limitations, and we did show you that in that failovers at different tiers produce slightly different end user experiences. So in the case of the central services failure, the user sessions, they're likely going to hang until the other side of the cluster takes over. They may be disconnected. So it's not 100% seamless. And in this particular example, we've done an active passive database replication. And if there's a database failure, the user sessions are probably going to hang. They're probably going to disconnect. There may be some various different end user experiences there until the other database is integrated and it's set up and active. Additionally, if there's any SAP background job running, it could get canceled, depending on what type of task is running and what occurs during the actual failover. So just something to be aware of. Other things to consider, and this is really kind of looking at the entire ecosystem. So for SAP, you can bring your own licenses to AWS, so that's a great advantage there. There may be different workloads, so for high availability, both sides are active. So if we have this spread across multiple availability zones, then you would have to, you're consuming those resources, or you have to pay for both sides of those. If you have other things within your ecosystem for ERP, other third-party add-on products, just consider that those may be have slightly different licensing models for high availability. Maybe there's some cost savings for that, so you don't have to pay 2x. So that's something to consider. What's the cost implications of that? Especially if you're only licensed to one server and you go to two, you may have to incur additional charges. And of course, why Syntax? We've got a lot of experience here. 25 plus years of managing customers, dedicated DevOps and SysOps team. And our focus really on automation and autonomous computing. So just to kind of summarize a couple things for us all here before we start opening up to questions. So high availability, it can really protect against faults during active operations. So this is something that is not for everyone. It can be expensive. It can be difficult to configure and administer, and it may not be something a lot of organizations want to take on. So there certainly is a cost reduction to achieving high availability within AWS. It's a shared resource model, so that's going to definitely drive down the cost. And of course, there's definitely advantages just having us, us at Syntax, help you with that process and manage that environment through our autonomous intelligent platform and the self-healing we build into the other monitoring. So high availability, it's a great fit for those critical applications that are the very backbone of your organization, such as ERP. Other things, they don't necessarily have to be running 24/7, 365. And in some of those cases, disaster recovery may be a more cost-effective solution. But if you're looking at a very small RPO and RTO, then this is certainly the solution that can be part of your considerations. Okay, well, over to you, moderator.
Yeah, thanks, Colin. Hey, it's Matthew again. So we do have a little bit of time left, folks, and if you're interested in asking some questions, we do have a question area for you to be able to ask questions. So we'll take a couple of minutes and maybe see if we can come up with a few questions that might be useful to everyone. So Thomas is asking about specific other failover software. And what we're showing you here is at least one way that Syntax actually orchestrates all this using some certified offerings that help to build the whole solution. Colin, I'm wondering if you could comment a little bit on why you may have taken the choices that you guys did to use the third-party, the other third-party solutions that you used. Was there a reason that you selected those versus others?
Sure, I'll turn that over to Antonio.
Thank you. Yeah, of course, there are other software from third-party companies that will allow you to do this clustering. Of course, Red Hat is supported. The other one is SIOS, that's also supported. And at Syntax, we use SUSE, but there's not a specific reason about that. Any solution will work and will provide the same capabilities.
Great. Hey, here's another interesting question. So Krishna is asking, while I understand HANA is being used for replication, what happens if my ERP is actually running on a Sybase database? How would you folks approach that?
Okay, this approach and this case is specifically for HANA. For Sybase, it's also possible to do this, but it's just another type of design at the database level. Of course, if your ERP is running under Sybase, you can do this very same configuration for the centralized services and ERS part. So that doesn't change. The only difference will be at the database level, and other mechanisms have to be implemented.
Okay, cool. Here's an interesting one. For the HANA database, do you consider the active configuration? And if so, how would you need to actually create a cluster for that?
Yes, for this cluster certified by SAP doesn't use active. It has to be always active passive. Yes.
These are great questions, by the way, folks. And I think if nothing else, what we're getting out of this is that there is a lot of choice, right? There's plenty of things the ways that you can do this. And certainly some of the principles that you're seeing here can be applied to your configuration. Sam is asking us, for an organization within a single country, can sufficient SAP high availability be configured within a single AWS availability zone? Or is the minimal to be able to do more than one availability zone? Great question, Sam.
Sure, I can, this call and I can address that. So in terms of, so you would first want to assess whether you need high availability. So we spent a little bit of time at the beginning of the presentation addressing that, because sometimes you may be thinking high availability, you might only need disaster recovery, and other times you're thinking DR, but you need high availability. Now, if we're going to have a AWS well-architected framework here, and we're going to do high availability, it's going to always be across multiple availability zones, simply because an availability zones may be spread across multiple data centers, and you don't get to pick which data center that goes into, but you certainly can pick which availability zones, and the availability zones are much further apart than any data centers within a particular availability zone. So certainly would say you'd want to try and spread that across availability zones. If you're looking to do HA within one availability zone, you really haven't taken any advantage of the cloud. That's what you might get within an on-prem solution. In terms of whether that is sufficient, we also need to ask the question, what are you trying to protect against? Power, natural disaster, or is it a nuclear type event? Availability zones protect you across pretty much everything except for the entire eastern or western seaboard going down.
At that point, we would hope that That doesn't happen. Another interesting question. What about support for Red Hat?
So Antonio, you want to address that?
Yes, as I said, this cluster configuration is also supported with Red Hat operating systems. Yeah, there's no special difference, but here at Syntax, we use most of the time SUSE, and we build clusters using SUSE. Yeah.
And folks, these are all choices, right? At some point, you start to make the evaluations and you try to determine what you think is going to work best for you. And generally speaking, if you have already purchased licenses or you already have other parts of your organization that are dedicated there, or that you've already invested in other solutions than what we're presenting here, we can help you figure that out. All the way up to and including this question: is Syntax tailored only for the AWS cloud?
Okay, no, I can answer. Yeah, so no, we're certainly not tailored for just one particular cloud. We support a variety of different clouds. I think that might have been the fourth slide in the deck. However, the majority of some of these advanced ERP designs initially start within AWS, certainly, and that is our go-to partner, simply because AWS allows us a huge amount of serverless computing through their Lambdas, automation. We have built out a number of features there as the stepping stone. We do have a multi-cloud approach where we support other clouds, but we're certainly here to talk about all the advantages of AWS and why that's our number one choice and starting point for any of these ERP HA designs on public cloud.
Thanks for that, Colin. At this point, I think we want to turn the mic back over to our friend Alexis to close out the show. And personally, I really appreciate the Syntax team taking the time to work with us on this. And thank you all for your time. Alexis?
Yep. Thanks so much, Matthew. Lots of great questions out there. Thanks for being engaged, everyone, and joining us today. We'd like to leave you with just a few links here on the screen where you can learn more about AWS and SAP on AWS, specifically with Syntax. Also, please remember to stay connected and complete the brief survey at the conclusion of the webinar. You'll be receiving an email with the on-demand recording, as mentioned at the beginning, in the next 2 to 3 days as well. So with that, thank you for everyone who joined, and also thanks to the group on the call who was able to present today. Really appreciate it, and everybody enjoy your evening or afternoon. Thank you.